a renewable source of energy. Hydropower. Hydropower or water power is a power derived from the energy of falling and running water, which may be harnessed or useful purpose.
Since ancient times, hydropower from many kinds of watermills has been used for irrigation and the operation of various mechanical devices. Since the early 20th century, the term has been used almost exclusively in conjunction with the modern development of hydroelectric power, which allowed use of distant energy sources. Water power is manifested in hydrology, by the forces of water on the riverbed and banks of a river. When a river is in flood, it is at its most powerful and moves the greatest amount of sediment. This higher force results in the removal of sediment and other material from the riverbed and banks of the river, locally causing erosion, transport, and with lower flow, sedimentation downstream. International institutions such as the World Bank view hydropower as a means for economic development without adding substantial amounts of carbon to the atmosphere.
Types of hydropower. Compressed air hydro. Where there is a plentiful head of water, it can be made to generate compressed air directly without moving parts. In these designs, a falling column of water is purposely mixed with air bubbles generated through the turbulence of a ventilator pressure reducer at the high-level intake. This is allowed to fall down a shaft into the subterranean, hag-roofed chamber where the now compressed air separates from the water and becomes trapped. The height of falling water column maintains compression on the air in the top of the chamber, while in an outlet, submerged below the water level in the chamber, allows water to flow back to the surface at a lower level than the intake. A separate outlet in the roof of the chamber supplies the compressed air.
Tidal power. Tidal power is taken from the Earth's oceanic tides. Tidal forces are periodic variations in gravitational attraction exerted by celestial bodies. These forces create corresponding motions or currents in the world's oceans. Due to the strong attraction to the oceans, a bulge in the water level is created, causing a temporary increase in sea level. When the sea level raised, water from the middle of the ocean is forced to move toward the shorelines, creating a tide. This occurrence takes place in an unfailing manner, due to the consistent pattern of the Moon's orbit around the Earth. The magnitude and character of this motion reflects the changing positions of the Moon and Sun relative to the Earth, the effects of Earth rotation, and local geography of the sea floor and coastlines. Tidal power is the only technology that draws on energy inherent in the orbital characteristics of the Earth-Moon system, and to a lesser extent in the Earth-Sun system. Other natural energies exploited by human technology originate directly or indirectly with the sun, including fossil fuel, conventional hydroelectric, wind, biofuel, wave and solar energy. Nuclear energy makes use of Earth's mineral deposits of fissionable elements, while geothermal power taps the Earth's internal heat, which comes from a combination of residual heat from planetary accretion, about 20%, and heat produced through radioactive decay, 80%. A tidal generator converts the energy of tidal flows into electricity. Greater tidal variation and higher tidal current velocities can dramatically increase the potential of a site for tidal electricity generation. Because the Earth's tide are ultimately due to the gravitational interaction with the Moon and Sun and the Earth's rotation, tidal power is practically inexhaustible and classified as a renewable energy resource. Movement of tides causes a loss of mechanical energy in the Earth-Moon system. This is a result of pumping of water through natural restrictions around coastlines and consequent viscous dissipation at the seabed and in turbulence. This loss of energy has caused the rotation of the Earth to slow in the 4.5 billion years since its formation. During the last 620 million years, the period of rotation of the Earth, length of a day, has increased from 21.9 hours to 24 hours. In this period, the Earth has lost 17% of its rotational energy. While tidal power will take additional energy from the system, the effect is negligible and will only be noticed over millions of years.
Generating methods of the tidal stream generator. Tidal stream generators, or TCGs, make use of the kinetic energy of moving water to power turbines, in a similar way to wind turbines that use wind to power turbines. Some tidal generators can be built into the structures of existing bridges, involving virtually no aesthetic problems. Land constrictions such as straits or inlets can create high velocities or specific sites, which can be captured with the use of turbines. These turbines can be horizontal, vertical, open, or ducted and are typically placed near the bottom of the water column. Tidal barrage. Tidal barrages make use of the potential energy in the difference in height or hydraulic head between high and low tides. When using tidal barrages to generate power, the potential energy from a tide is seized through strategic placement of specialized dams. When the sea level rises and the tide begins to come in, the temporary increase in tidal power is channeled into a large basin behind the dam, holding a large amount of potential energy. With the receding tide, this energy is then converted into the mechanical energy as the water is released through large turbines that create electrical power through the use of generators. Barrages are essentially dams across the full width of a tidal estuary. Dynamic tidal power. Dynamic tidal power, or DTP, is an untried but promising technology that will exploit an interaction between potential and kinetic energies in tidal flows. It proposes that very long dams, for example 30 to 50 kilometers length, be built from coast straight out into the sea or ocean without enclosing an area. Tidal phase differences are introduced across the dam, leading to a significant water level differential in shallow coastal seas, featuring strong coast parallel oscillating tidal currents such as are found in the UK, China, and Korea. Tidal lagoon. A newer tidal energy design option is to construct circular retaining walls embedded with turbines that can capture the potential energy of tides. The created reservoirs are similar to those of tidal barrages, except that the location is artificial and does not contain a pre-existing ecosystem. The lagoons can also be in double or triple format without pumping or with pumping that will flatten out of the power output. The pumping power could be provided by access to grid demand renewable energy from the example wind turbines or solar photovoltaic arrays. Excess renewable energy rather than being curtailed could be used and stored for a later period of time. Geographically dispersed tidal lagoons with a time delay between peak production will also flatten out peak production, providing near base load production though at a higher cost than some other alternatives such as district heating renewable energy storage.
Wave power. Wave power is the transport of energy by ocean surface waves and the capture of that energy to do useful work, for example, electricity generation, water desalination, or the pumping of water into reservoirs. A machine able to exploit wave power is generally known as a wave energy converter. Wave power devices are generally categorized by the method used to capture the energy of the waves, by location and by the power takeoff system. Location is a shoreline, near shore, and offshore. When evaluating wave energy as a technology type, it is important to distinguish between the four most common approaches: point absorber buoys, surface attenuators, oscillating water columns, and overtopping devices.
Point absorber buoy. This device floats on the surface of the water, held in place by cables connected to the seabed. Buoys use the rise and fall of swells to drive hydraulic pumps and generate electricity. The presence of the buoys may affect fish, marine mammals, and birds as potential minor collision risks and rusting sites. Potential also exists for entanglement in mooring lines. Energy removed from the waves may also affect the shoreline, resulting in a recommendation that sites remain a considerable distance from the shore. Surface attenuator. These devices act similarly to point-absorber buoys, with multiple floating segments connected to one another and are oriented perpendicular to incoming waves. A flexing motion is created by swells that drive hydraulic pumps to generate electricity. Environmental effects are similar to those of point-absorber buoys, with an additional concern that organisms could be pinched in the joints. Oscillating water column. Oscillating water column devices can be located on shore or in deeper waters offshore. With an air chamber integrated into the device, swells compress air in the chambers, forcing air through an air turbine to create electricity. Significant noise is produced as air is pushed through the turbines, potentially affecting birds and other marine organisms within the vicinity of the device. There is also concern about marine organisms getting trapped or entangled within the air chambers. Overtopping device. Overtopping devices are long structures that use wave velocity to fill a reservoir to a greater water level than the surrounding ocean. The potential energy in the reservoir height is then captured with low head turbines. Devices can be either onshore or floating offshore. Floating devices will have environmental concerns about the mooring system affecting benthic organisms becoming entangled. There is also some concern regarding low levels of turbine noise and wave energy removal affecting the near-field habitat.
The International Hydropower Association. The International Hydropower Association is a not-for-profit international organisation representing the hydropower sector, focused in particular on electricity generation, water management and related industries. The International Hydropower Association has members in more than 80 countries drawn from organisations and individuals in industry, international organisations, governments, scientific and academic institutions and civil society. The organisation states one of its purposes is to address the role of hydropower in meeting the world's growing water and energy needs as a clean, renewable and sustainable technology.